So I'm Himanshu, and it's always a pleasure to be a part of this amazing crowd. Some crazy moments that we had last year, I can still see few familiar faces, picture time, and it was an amazing conference last year as well. Today I'm here in front of you to speak about the newest kid on the block, the talk of the town, the latest addition to Angular's reactivity story, the httpResource API. httpResource API has been tried to be introduced as the latest candidate into Angular's reactivity story. If we try to see how we used to do the HTTP request traditionally, the developer is right now responsible to make an implicit request. Rather, you would use a subscription model or try to use an effect. That has a lot of overhead for you to do, right? And the often issue that we see is unsubscribe karna bhul gaye, right? You ultimately forget to unsubscribe from it. I'll try to cover the benefits that come out of the httpResource API, a slight usage and the API example. We'll do a comparison very slightly about the traditional HTTP client as well as the new httpResource API. I'll try to leverage all the knowledge that I gave you into an application. It's a small application I created where I have used extensively the traditional HTTP client, but we'll try to migrate one simple code snippet to the new httpResource API. And finally, we will delve into performance. I might skip certain slides due to time constraint, but I'll ensure you get to see all of the code. And amidst all of this, we'll try to answer finally, do we need HTTP client anymore, or is it really dead? But as the gentleman in the movie says, plane utarne se pehle plane ke baare mein seekhna zaruri hai, right? And he is very apt today. So before we delve into httpResource API, let's try to understand what's a resource. A resource is basically a pattern. If you see the resource RFC, you must have come across two patterns, which are resource pattern and the suspense pattern, right? It's an async primitive that has been given to you. Basically, what it tries to do is all the HTTP statuses, whatever is the current status of your HTTP request, as well as the final result that it holds, it has been exposed to you as signals. Resource pattern kind of gives you the explicit asynchronicity. It always have a value, no matter what, and if it is in a loading state, it will always try to have a value as undefined. Let's try to quickly go through the benefits. Reactive updates. When you write a HTTP resource, you say, okay, my data is dependent on so-and-so signal, and whenever that signal value changes, I want to declaratively fire the request. So you give the responsibility to Angular in order to fire up your request rather than implicitly calling on every change. Less boilerplate. As I said, nowadays you don't have to write subscriptions or effects to maintain your particular HTTP request. Consistency and testing. Ultimately, your HTTP interceptors, your existing testing utilities, they all stay the same. So the familiarity that you have working with these particular instances, it's all the same as it is. Improved responsiveness. Now consider a scenario that we all have worked with, right? You have a search box and your user is typing numerous characters randomly, and you are trying to make an HTTP request for every group of characters. Now you are responsible for canceling the stale request or debouncing it, right? All that is baked up into the httpResource API. So the switch map strategy, the observables that we try to kick in, those all are actually baked in. Type safety and validation. httpResource API exposes a very nice option, a very neat one, which is known as parse. So you can integrate your type safety validation or schema validation libraries like Zord, and you can easily have a good runtime compilation type safety as well as what you are used to in the development mode. Let's see this code snippet, right? So it creates a resource tied to an HTTP request, and I say my HTTP resource is right now binded to current user ID. So as soon as the ID changes, a new request should be fired. Right now, I'm not using any subscribe or anything else. I have a very neat option there as well, which is default value. So as I said earlier, HTTP resource exposes its status as well as its final value as signals. So it will always hold a value. If you don't define an initial value, it will be undefined, and then it is up to you to how you handle it on the UI. So rather than that, I can leverage what is known as the default value. It returns an object of the type http resource ref that contains knowledge about state and the final result. One thing to note here is all these requests are fired eagerly, right? So as soon as you make this request into the injection context, the resource will be fired up. But we do have a way how we can control this eager behavior. You get to pass all the options that you're used to, right? All the advanced configuration. You can have your methods, headers, body, params, etc. And as I said, there's a neat way how you can prevent the eager behavior. So you can right now say, okay, if my search term is there, then only fire up my advanced configuration options using the HTTP resource. Otherwise, it will be undefined. So you will get rid of the HTTP resource behavior being fired eagerly. Now, if you want to make requests for certain other data types, like a binary blob, a text, or let's say an array buffer, that all is also possible using the HTTP resource API. Certain reactive properties, right? So it exposes a lot of signals out of the box where you can leverage the values that it exposed. So the value signal is the actual result that is holed up into the HTTP resource. Similarly, you get error, status, is loading, status code, headers, and progress. Progress is the most interesting one. So if you come up across where you need to show the download progress or upload progress to your UI client, this is what you're going to be using. So all of these reactive properties are signals which are exposed out of the box from the HTTP resource API, right? So you need not maintain few more signals just to calculate your error. You need not create a loading signal just to say, okay, my app is right now loading. Usage in the component is fairly simple. You say this is my resource, and if it is loading, so and so will be my behavior, and finally when the value is there, it will show the value. So Angular's chain detection will update the DOM whenever the data arrives or changes. Schema parsing, as I said. Parse is a neat option that helps you try to integrate schema validations library like Zod. But I was talking to one of our fellow speakers, and there's also a use case for parse. If you want to manipulate the data that is coming from your HTTP resource type, that also you can do in the parse option, right? And apart from that, we have seen default value as well as a custom equal function that transform the resource before it is set. So 3 options I've shown so far into the HTTP resource API, which is parse, default, and equal. And there are many more, so do read the documentations to know more. Right now, it feels like HTTP client, it's really over. There's nothing more left to it. All the features have been exposed by what we see in the HTTP resource. Let's do a quick comparison where HTTP client stands as of now in comparison to the HTTP resource API. Reactivity of data flow. As I said, with HTTP client, the whole data flow has to be orchestrated by the developer. You need to write your subscription, switch map, async pipe, and what all not, right? And you should also remember to unsubscribe from the observable streams that you just created. You get rid of all that mess when you use HTTP resource. Eager versus lazy loading. HTTP client always returns a cold observable that won't execute until you subscribe to it. So you are responsible for doing that. But in case of HTTP resource, you can have an eager loading behavior, and you can still control it with the close snippet that I showed you. Boilerplate and state management. You need not create different signals for loading state to control the error state to have different headers. All of that is inbuilt into the HTTP resource API. Cancellation and stale data. Our search box example, right? So the switch map strategy pattern is already built up into the HTTP resource API. You need not write a switch map operator just to cancel the stale request. Integration with Angular features. So the most important one is transfer cache option. It tells, and it actually prevents duplicate requests on the server side. So it tells your application, okay, first of all, render my request on the server side, and now if the data is available, go ahead and reuse it on the client side, right? And had you been using the traditional HTTP client API, you will have to use or manually call the transfer state APIs. HTTP client really shines off for one-off calls or imperative patterns, like you want to make an HTTP request on a click of a button. But HTTP resource is geared towards continuous or declarative data needs. You just have to declare this is the sort of data that I need, And eventually, Angular is responsible for keeping the state updated. As a developer, you can choose what fits your use case. Declarative signal fetching with HTTP resource or an imperative control. Both can coexist and both use the same HTTP client. So coming back to a question, do we need HTTP client anymore? So far, yes, right? So the underlying mechanism stays the same. These are implementation details which can change in future, but so far, yes. Using all this knowledge, right now it's time to expand. Let's try to go through a small code snippet. I'll try to maximize this one. So I have this small application created. I'm trying to hit the Marvel's Comics API. If you see, I have two modes to this application. One is the gallery mode, which you see right now, and it is integrated with infinite scrolling, right? So as soon as you scroll, you will have more requests. And this is all based on the existing HTTP client API. But what we are going to do is, this is play mode. So if you enter a wrong character name, it will show some sort of an animation. But I know this character's name is A-bomb, and if I enter that correctly, I'm granted with a confetti, and I move to the next one. And I'm using a traditional pagination pattern here. So our goal is to migrate this particular API from HTTP client traditional ways to what we need to know right now, the HTTP resource API. Let me zoom this a bit. Okay, so the HTTP client right now, I'm just making a simple request to which I actually subscribe into my function, which is responsible for fetching all the images that you see, right? So what I'm trying to do right now is just trying to unblock a piece of code that should be responsible for migrating my application to HTTP resource API. I do not need to use the parse option so far, but I'm interested in using an default value for my application, so that I don't get undefined all the time. So once this change is done, I'll go into my game mode component, and I don't need this signal that I was maintaining earlier. Neither I need to call the pagination API that fires up a request explicitly all the time. So I get rid of that. I'll try to use the resource value that we have seen just a moment ago. And I'll try to use the signal that is exposed by the HTTP resource rather than maintaining a loading signal on my own. And when I switch the modes to play mode or gallery mode, I don't want to trigger one more unnecessary request. So I'll come in this piece as well. Now, doing all of this, I right now feel the application should run as it was running earlier. So let's go to the play mode. And if you see, this request is right now being triggered from the chunk. If we do the next pagination, yes, it is still triggering from the chunk API. So as you see, this has been leveraged using the HTTP resource API rather than the HTTP client. But how does it actually happen? Where's the magic, right? We talked about dependent signals and states. So when you click next, you are telling your application, okay, go to the next page. So increment the current page number. What I've done so far is, if you go into the game mode component, I'm just trying to set some params, right? So this is where the magic happens. If you go to the params method, I see I'm trying to increment the current page value. So when I click on next, it goes from 0 to 1, 1 to 2, and so on. As soon as current page is updated, a computed signal comes into play. This is responsible for generating the query string. So the query param string signal is a computed signal which gets updated as soon as the current page is updated. Once that is done, I say in my HTTP resource, my whole resource triggering is dependent on the query param string. So I click next, the current page count updates, query param string updates, and so my HTTP resource API fires a request on its own. I need not do any manual action. Neither I am responsible for clicking on subscribes or unsubscribes or responsible for getting rid of them at the end of my application. So this is how neat it is to use HTTP resource API. And I feel you all should be feeling empowered and enabled enough to change almost everything in your project for data fetch operations from HTTP client to going forward with HTTP resource. Going back to our presentation, let's try to dig in the last few features, what comes as a performance benefits to our particular application. Optimized change detections, right? So everything right now with the HTTP resource API is dependent upon signals. So HTTP resource, even if you are trying to use an application which is in zoneless mode, it goes for more direct and potentially faster update cycles. Auto cancellation for efficiency. We talked about this a couple of times. So the switch map pattern is baked in, so you get much more auto cancellation efficiency there. Server-side rendering options. As I said, this is the most neatest one of them all. So the transfer state APIs are implicitly called when you use HTTP resource, but had you been using HTTP client, you would have to actually call all these transfer state APIs on your own. This prevents duplicate requests from happening. Last one is the memory and cleanup. So each HTTP resource is tied to the lifecycle of the context. And in most of our cases, it's generally dependent on the component. So as soon as the component destroys, your HTTP resource API will stop working. So it's an architectural safeguard that comes for free with the resource pattern. Having said that, I want to give you two key resources that you can leverage your knowledge more with. One is the resource RFC1, which talks about the architecture. And second is the resource RFC2 that talks about the API that we have explored. Both of them have been concluded, so you can actually see what was the community contribution to it and how and what is the next future for HTTP resource API. Finally, to conclude, I write a lot of blogs over Medium, so if you like what you have heard so far, try to go on the Medium blogs as well. The demo code that we saw for a short while, you can explore that demo code. It's an open source repository, and even you can try to maintain the whole HTTP client. I have migrated it to the new HTTP resource API. So you can also leverage that, and it is valid for multiple cases. So in that, I have infinite scrolling, as well as I have traditional pagination. So if you have so far loved what you heard and what you enjoyed, do remember to follow me around. I'm here for the next of the day. That was my talk, folks. Thanks for listening patiently. Enjoy the conference.